One-way repeated measure ANOVA, or alternatively called repeated measure ANOVA, or within subject ANOVA, followed by pairwise comparison in Excel, SPSS, Jamovi, and GraphPad Prism softwares. One-way repeated measure ANOVA, or alternatively called repeated measure ANOVA, or within subject ANOVA, followed by pairwise comparison in Excel. The test is used when there are one dependent variable and one independent variable that have several levels in it, or groups that are related. Here in this Excel sheet, I had inserted a data for 50 participants. Those participants were enrolled in a study that investigates the effect of exercising on body weight. So the dependent variable was the body weight measured in kilograms. The independent variable, which is time points or months in this case, have 5 levels in it. Each individual participant, the weight for each has been measured at different multiple point in time. The weight was measured at the beginning of the study, for which is labeled as month, and then after 1 month, after 2 months, after 3 months, and after 4 months. The independent variable have 5 levels in it, and these levels or these data are related since each participant has participated in all the 5 time points. To find out whether exercise can have an effect on the body weight and whether the exercise can lower the body weight, then one-way repeated measure ANOVA will be used, as the same individual has been measured at several different time points. To perform one-way repeated measure ANOVA, click on Data, select Data Analysis, and then select the ANOVA To Factor without replication. Click on OK. A window will appear for ANOVA To Factor without replication. To input the range, click on the arrow here, select the 5 levels, all the data with the labels from month 0 to month 4, and tick on the labels, click on OK. 2 tables generated. For the first table, the mean and the variance is given for each level within the independent variable. The most important table is the ANOVA Table. As shown from the ANOVA Table, ignore the rows and look at the column, since we are comparing here within subject, within the related data. And as shown here, the p-value is less than 0.05, and if we reduce this decimal point, and we can see here it is below than 0.05, so there is a significant differences between the means of the related data. So this data shows that there is a difference in the weight within subject, within the related data. Now this one-way repeated measure ANOVA will only calculate and determine whether there is a difference within subject or subjects, and to find out which pairwise levels will have a significant differences in the weight loss, then comparison or pairwise comparison between two levels will be performed using t-test, paired t-test. As these data are related, then the choice to go for is the paired t-test. To perform the paired t-test, I'm going to select a few examples here. The month 0 with month 1 and paste it here, month 0 and paste it here, and then select month 2 and paste that here. To perform paired t-test, click on data analysis and then scroll down to the t-test paired to sample for means. Click on OK, and in the new window for paired to sample, input the variable for range 1. The variable for range 1 is the first level in this data, and for the variable 2, select month 1, and for the label, click on the label and tick on the label and then click on OK. A table is generated for the paired t-test, and as shown here, the p-value is greater than 0.05, so there is no significant differences in the weight between those who have exercised for 1 month compared to the beginning of the study. To perform the second pairwise comparison between the beginning of the study and exercising for 2 months, click on data analysis, again select the paired to sample for means, click on OK, select the range. Here the range again is 0 time or month 0, and for the variable 2 input, select the month 2 data and then keep the tick on the labels. Click on OK. A table is generated with p-value as shown here for the two-tailed significance. Here it is shown that the p-value is less than 0.05. If we reduce the decimal, we can see that there is a p-value that is less than 0.05, and that indicates there is a significant difference in the mean for the weight between month 0 and month 2, which indicate that exercising has lowered the body weight. So this is the way to perform one-way repeated measure ANOVA in Excel, followed by pairwise comparison. One-way repeated measure ANOVA or repeated measure ANOVA, or sometimes it is called within subject ANOVA, followed by pairwise comparison in SPSS. The test is used when there are several independent variables that are related and one dependent variable. Here in this SPSS data view, I had inserted a data from study that included 50 participants in it, and each participant had enrolled in this study, and the weight of each individual participant was measured and scored at different time points. So the weight is the dependent variable, and the time point is the independent variable. So we have here 5 levels of independent variables. 0, month 0, beginning of the study, 1 month, 2 months, 3 months, and 4 months. In this study, there are 5 related independent variables that the weights in which the weight of each participant has been measured at separate time points, and each individual has been asked to exercise daily for 1 hour for the period of the study, and the weight was measured post 1 month of exercising, 2 months, 3 months, and 4 months, and time 0, which is the beginning, at the beginning of the study, was considered as the month 0. To find out whether there is a difference in the weight between those 5 different related levels or groups based on the exercise, and whether the exercise have an effect on the weight of each participant, and since each participant had participated in the study and measurement taken at different time points, so these data are repeated data. So one way repeated measure ANOVA will be used to find out whether an exercise will have an effect on the weight loss. To do the analysis, click on Analyze, scroll down to General Linear Model, and then select the repeated measures. In this new window, for within subject factor name, we're looking here at time points or months. Let's call it months or months. Since we have 5 independent variables or 5 levels, insert number 5 and then click on Add, click on Define, and in this new window, select and drag all the 5 levels into the within subject variables for months, and then click on Plots, select the months, move it to the horizontal axis, then click on Add, click on Continue. Post hoc test will not be selected as we do not have more than 1 factor here. Click on EM means and select the months and move that into display means for months, and then tick on the compare mean effect and use the LSD. Click on Continue, and on Save, click on the unstandardized predicted values and click on Continue. For options, select the descriptive statistics for displaying homogeneity test. However, homogeneity test cannot be done in these settings. And then estimated or estimate of the effect size, click on it, click on Continue, and then click on OK. Several different tables will be generated with a plot toward the ends here. So in the first table here, as shown here in this warning, it shows that homogeneity specification in the print subcommand will be ignored because there are no between subject or subject factors. For the first table within subject factors, it shows that we have 5 levels, months 0 to months 4. The descriptive table shows the mean and the standard deviation for each independent variables for months 0 to 4. For the next table, which is an important one, which is Motley test of sphericity. Again, this test is required and it is one of the assumptions that has to be fulfilled or met to perform a one-way repeated measure ANOVA. And it shows that the p-value is less than 0.05, and the sphericity, which is one of the assumptions required for performing the one-way repeated measure ANOVA, has been violated. However, this is not of a concern. Test of within subject effect showed that the p-value when the sphericity is met or when the sphericity is not met, as there are alternative tests, and since the sphericity has been violated, we are going to use here the greenhouse geysers and Heinfeld outcomes or p-value. Again, this test shows that there is a significant differences between the independent groups or variables, 5 groups. The next table, which is an important one, which shows the pairwise comparison between the 5 levels or 5 independent variables. The first one, which is 0 month compared to 2, which is month 1, and then to month 2, and then to month 3, and then to month 4. This table shows whether there is a significant differences when comparing 2 groups, comparing the mean for the 2 related groups or levels. Again, from month 0 to first month, there is no significant differences in weight loss. However, from month 0 to month 2, there is a significant differences in weight loss when the participant exercised for 2 months, and same for when individual exercise for 3 months and 4 months. So this table will determine which 2 groups are related groups or related levels have a significant differences in the mean. And finally, the plot here shows the estimated marginal means, and from this it's clearly shown that for the month 1, which is 0 at the beginning of the study, compared to the weight measured after 1 month, there is no significant difference in the mean. However, there is a decline in the weight for participant after exercising for 2 months, 3 months, and 4 months. There is significant reduction in the weight when an individual exercised for 4 months relative to the beginning of the study. So this is the way to perform one-way repeated measure ANOVA in SPSS. one-way repeated measure ANOVA, or alternatively called repeated measure ANOVA, or within subject ANOVA in Jamovi. The statistical test is used when there are dependent variable, one dependent variable, and one independent variable that have several levels in it, or several groups that are related. Here in this data view in Jamovi, I had inserted an outcome, a data extracted from a study investigating the effect of exercising, sporting on the body weight reduction. There are 50 participants in this study. Each participant body weight was measured at different time points. The participant has been asked to exercise daily for 1 hour, and the body weight was measured at time 0, which month 0 at the beginning of the study, then after 1 month of exercising, and then after 2 months, 3 months, and 4 months. So here in this data we have one independent variable, which is the time or the months, and it have 5 levels in it, or 5 groups. These groups or levels are related since they are measured from the same participant, and the dependent variable is the weight measured in kilograms. To find out whether there is an effect of exercise in body weight reduction, and whether there is a difference between the levels for these data within that independent variable, then one-way repeated measure ANOVA will be used. To perform the analysis, click on the ANOVA here, select repeated measure ANOVA, a new window will appear, and since we have one independent variable that have 5 levels in it, or 5 related groups, months 0 to 4, and we only have here one independent variable, then we need to add here levels, level 3, then level 4, then level 5. Select these 5 levels and drag them into the repeated measure levels here, repeated measure cells as shown here. Simultaneously, a repeated measure ANOVA table is generated for within subject effect, as here we are looking at the differences within the subject or within the levels. As shown here, there is a significant level. The p-value is less than 0.05, and that indicates that there is a significant differences among all these 5 levels. As we don't have here more than one factor, so between subjective effect is not calculated. So if we scroll down here, we are not going to add anything between subject effect or no covariate. Click on the model here And in the model here, repeated measure component, we have only repeated measure factor 1, which is the time or the months, and there are 5 levels in this independent variable. Click on or assumption checks. One of the assumptions required to perform one-way repeated measure ANOVA is to check the sphericity test. And the sphericity test here, once you click on the tick the mark here in this box, assumptions test is performed and a value is generated for the Motley test of sphericity. The p-value is less than 0.05, and this table shows that the assumption for sphericity has been violated. However, for a one-way repeated measure ANOVA, an alternative test can be used, such as greenhouse geysers and high field test. We could also click on homogeneity test. Again, there will be no table generated as we do not have more than one factor here. Click on the post hoc test here. Drag the repeated measure factor to the next box. As shown here in this post hoc test table based on Tucky test, this test will compare pairwise levels within the independent variable. So level 1, which is month 0, is compared to level 2, 3, 4, and 5. And level 2 is month 1. And then level 3 is month 2. 4 is month 3. And 5 is month 4. So there is no significant differences between level 1 and level 2. However, there is a significant differences between level 1 and 3, 1 and 4, and 1 and 5. Click on the estimated marginal mean and drag the RM factors into the marginal means, and a plot is generated for the 5 levels on the x-axis as shown in the plot here, and for the body weight on which is the mean body weight on the y-axis. Again, it's shown here that there is not much difference between level 1 and level 2 in terms of body weight reduction. So this is the way to perform one-way repeated measure ANOVA in Jamovi. One-way repeated measure ANOVA, or alternatively called repeated measure ANOVA, or within subject ANOVA, followed by pairwise comparison in GraphPad Prism. The statistical test is performed when there are one dependent variable and one independent variable that have several related levels or groups. Here in this GraphPad Prism, I had inserted data from a study investigating the effect of exercising daily for 1 hour on the body weight. So there are 50 participants enrolled in the study, and each participant weight was measured at different multiple point in time. The weight of the individual, each individual, is measured at time 0, beginning of the study, and then after 1 month, and then after 2 months, 3 months, and 4 months. The weight was measured in kilogram, and each individual has participated in the study, and measurements were taken at different time point. So the independent variable here, which is the time or the months, have 5 levels in it, month 0 to month 4. To test and determine whether there is an effect of exercising on the body weight, and since we have here a related data, 5 different related levels, then one way repeated measure ANOVA will be performed to find out whether exercising can lower the body weight on a period when a person exercise for 4 months. To do the test, click on Analyze, and the software will promptly select one-way ANOVA, and on the right box states analysis or analyze with data set for the 5 levels. Click on OK. Since here we have a related levels, the experimental design will be each row represents matched or repeated measure. And for assume Gaussian distribution of residual, yes, use ANOVA since our data here is parametric. And for assuming sphericity, select no use geyser greenhouse correction recommended choice. Click on repeat or repeated measure, and in the repeated measure click on analyze using repeated measure ANOVA, since we have here same individual measured at different time points, so it is a repeated measure. And for multiple comparison, we intend to compare each level with another level, so pairwise comparison for all possible combination. So select the compare the mean of each column with the mean of every other column. Under the options, select the multiple comparison test and choose the Tucky test as the choice for comparing the levels. And then for residual, no more choices, just click on OK. 2 outputs will be generated. The first one is the ANOVA result. Repeated measure one-way ANOVA result showing that the summary F ratio is calculated and the p-value is significant, as the p-value is less than 0.05. So there is statistically significance in the mean for all the 4 possible levels, and the geyser greenhouse epsilon here is given. Scroll down to the ANOVA table. What is interesting in this table is the row that shows between column, as this repeated measure ANOVA is within subject test. And as shown here, there is a significant difference as the p-value is less than 0.05. So this repeated measure one-way ANOVA suggests that there is a difference in the mean for the 5 levels. To find out which pair or combination of pair that have a significant differences in terms of weight, lost, then multiple comparison will be used using Tucky test. In Tucky test, the 5 levels, which is month 0, is compared to month 1, 2, and 3, and 4. And for month 1 is compared to 2, 3, and 4. And month 2 is compared to month 3 and month 4. And month 3 is compared to 4. So this Tucky test will examine all possible combination, pairwise combination between levels and determine whether there is a significant differences in the mean or not. As shown here, there is no significant differences in the weight for the level 0 and level month 1. However, there is a significant difference between level 0 and exercising for 2 months, and there is a reduction in the weight, and so on. So this is the way to perform one-way repeated measure ANOVA in GraphPad Prism.